Hello students, welcome to this class again. So today we are going to study about mirror formula. So actually what is this mirror formula? Okay, so we have studied in the last class how to draw the ray diagrams and how to identify the characteristics of the image formed when object is kept at different places in case of convex mirror and concave mirror. When we observe the ray diagrams, suppose if anybody asks, when we keep the object beyond C, where do you get the image? Then we may say that the image is obtained between C and F. Okay, but if exactly we ask, that is, if the focal length is given, let me say a concave mirror of focal length 10 centimeters, and object is kept at 30 centimeters, where do you get the image? If they give the numerical values like this, then we may not be able to say exactly with the help of the ray diagrams. So in this kind of numerical problems, in order to solve these problems, we are going to use the mirror formula. Okay, so let me write what is the mirror formula. So mirror formula is given by 1 by F is equal to 1 by U plus 1 by V. This is the mirror formula. So what is F? F is the focal length. The focal length. U is the object distance. Object distance. And V is the image distance. Image distance. What is the focal length? The distance between the focus and the pole, right? And what is object distance? The distance between the object and the mirror. Generally we take till pole. And what is image distance? The distance between the image and the pole of the mirror. Okay, so this is the mirror formula. Now we are going to derive the mirror formula. So let us start the derivation, children. Please consider the diagram. Already I have drawn a concave mirror here. This is the pole, this is the focus, and this is the center of curvature. Let me draw an object beyond the center of curvature. So this is an object and I denote it as AB. Okay, AB is the object. Now from the object, you know the rules to draw the diagram, children. So we are going to draw two light rays. One is parallel to principal axis, and that is incident at X. This is X, children. And that light ray is reflected through F. Okay. Now, generally we used to draw the second incident light ray which passes through F. Okay, that is the second rule. Now here we are going to use the third rule, that is the light ray can pass through the center of curvature also. If the light ray passes through the center of curvature, then it retraces its path. So we are going to take the third rule. With any of the rules we are going to get the image. Okay, this is the second incident light ray, and that is incident at, let me say, Y. This is incident at X and this is incident Y. And this is the incident ray and it retraces its path. It goes back. So this is the first reflected ray and this is the second reflected ray. Both are meeting at this point. So you are going to get the image at this particular point. Let me say this is the image. Okay. So this is A dash, this is B dash. So A dash, B dash is the image. Okay. And now you have to draw a normal from X towards the principal axis. And let me show that point as P dash. A normal is drawn from X onto the principal axis, and that point we are denoting it as P dash. Okay. Now let us start our derivation. So when you look at this diagram, children, now look at this triangle ABC. A, B, C and C, A dash, B dash. These two triangles. Okay, so let me draw here. It's something like this. So compare triangle A, B, C and A dash, B dash, C. Okay, so when we compare, they both are similar triangles. They are similar triangles. Okay, so from the diagram we can see here. So let me say it something like this. So it is A, B, and this is C, and this is A dash, and this is B dash. So this is what you can see here, these two diagrams. So since they are similar, why do you say they are similar triangles? Because this side and this side are 90 degrees and these two angles are vertically opposite angles, and then definitely this angle will be equal to this angle. So the three angles are same, equal. So therefore these two triangles are similar triangles. So if these two triangles are similar, then the ratio of their corresponding sides will be equal. So we can write AB. We can write AB by A dash B dash. AB by A dash B dash is equal to AC by A dash C dash. AC by A dash C dash. Okay, so this is equation 1. This is equation 1. And let me show this as point 1. Now, secondly, look at the triangles, that is A dash, B dash, F and F, X, P dash. Okay, let us compare these two triangles. Now, triangles X, P dash, F and A dash, B dash, F are similar triangles. Again, are similar triangles, these two triangles. So we can write XP dash, XP dash, XP dash by A dash B dash is equal to P dash, FP dash, FP dash by FA dash, by FA dash. This I can take it as equation 2. We have compared first these two triangles. Next we have compared these two triangles. Okay, right. Now from figure, look at this figure, children. So from here you have drawn a parallel light rays and which is incident X. So from the figure we can say AB is equal to XP dash. From figure, AB is equal to XP dash. Okay, therefore equation 2 can be written as, equation 2 can be written as, equation 2 can, in the place of XP dash we can use AB by A dash B dash is equal to FP dash by FA dash. So this you can take it as equation 3. Equation 3. Okay. So this you can, this is third point. Okay. Now coming to the fourth point. Now compare equation 1 and 3. Equation 1 and 3. I got here, when I compared this first two set of triangles, I got equation 1. Then second two set of triangles, equation 2. Okay. Then equation 2 can be written in this form. And now I am comparing 1 and 3. From 1 and 3. From 1 and 3. So looking at 1 and 3, see children, left hand side, both the equations are same. AB by A dash B dash, AB by A dash B dash. So therefore I can equate RHS of these two equations. So AC by A dash C dash is equal to F P dash by F A dash. This is the equation 4. This is equation 4. Okay children, now the fifth point. Now coming to the fifth point, a very important thing which you have to understand children. So for smaller aperture, actually the definition that is in defining the important terms related to mirrors, we have defined aperture. What is the aperture? The reflecting portion of the mirror is what we call as an aperture. Generally the mirrors which we are considering here, they are of very small aperture. Let me explain. Suppose this is a sphere, and if you are cutting a concave mirror in this way, and then you are painting this part, then this part is what we call as an aperture. Okay, so generally actually the mirrors which we are using here are a very small aperture, that is, it is like this. Almost they look like plane surfaces. Okay, so like this. So if you take such mirror, it is very difficult for us to draw and explain. Okay, so we have taken like this, but they are made up of very small aperture. So what is the main point here is, for smaller aperture children, so what happens is that suppose when the light ray, so when incident light ray comes in and when it is incident here, so this P dash and P both coincide each other, that is these 2 points coincide each other almost. Okay, so therefore for smaller aperture, P dash coincides with P, that is in the place of P dash we can write P. So therefore equation 4 becomes AC by A dash C dash is equal to FP. In the place of P dash I have taken P now. Why? Because this is approaching, okay, for smaller aperture, by FA dash. Now this is equation 5. I hope you understood this equation. Okay, right. Now as I proceed forward, now this AC, now coming to sixth point. Now look at this AC. Now from the figure, this AC can be written as AP minus CP. Can I write this? I want this AC. Okay, so for that I have taken this value and I am subtracting this part. Therefore AC is equal to AP minus CP. Next, let me write this A dash C dash. Where is A dash C dash? Okay, A dash C, no C dash. A dash C. So how can you write A dash C? That is PC minus PA dash. I hope you are following this. Now FP. So there is no need of changing FP. It is written the same FP. Now next is FA dash. How can you write FA dash? PA dash minus PF. Okay, so here actually what we are trying to do, children, why is that this AC is written as AP minus PC, is that we want to express all this lengths in terms of object distance, image distance and the focus. Okay, so that is the main purpose of writing in this way. Now I am going to erase this part, so please concentrate. I hope you have taken this in the notes. You can take down. Okay, now I will proceed. Okay. Now, seventh step, children. So AC is equal to, see what is AP now? Let me write AP is equal to, what is AP? From the picture, children, AP. AP. So this is object. So this is called object distance. So I write AP is equal to U. And let me say what is CP. 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 This is a radius. Okay. So CP is equal to radius. And the radius I can write as 2F, 2 times of focal length. Next, PC. PC, CP both are same. Okay. CP and PC both are same. And that's why let me say that is also equal to PC. We have written here. Now PA dash. PA dash. PA dash. This is the image. So therefore this distance is called as image distance and it is represented with V. And what is FP? FP. FP is this distance. And that is a focal length. Written as small f. And PA dash. PA dash already we have written here. PA dash. And PF is already here. That is FP or PF. Both are same. Okay. Now equation, that is this we can write this. Okay. So equation 5 can be written as, coming to the 8th point, equation 5 can be written as AC. What is AC? AP minus CP. What is AP? AP is U. U minus CP. What is CP? That is R, that is 2F. Minus 2F by A dash C. What is A dash C? It's not C. A dash C, that is PC. Where is PC? It's this. 2F. 2F minus PA dash. What is PA dash? PA dash is V. Is equal to FP. What is FP? FP is nothing but here F. F by FA dash. What is FA dash? PA dash, that is V minus FP. That is nothing but F. Okay, I hope you understood this. So this fifth equation, equation 5, can be written in this form. Okay, now cross multiplication. Cross multiplication, that is U minus 2F into V minus F is equal to F into 2F minus V. Now you are multiplying U into V, UV minus UF minus 2FV minus of minus plus F square. 2F square. 2F is equal to F into 2F square minus FV. Minus FV. Okay. So on solving this, so I have here 2F square and here 2F square. I am going to cancel this. Okay. And I am bringing this minus FV this side. Already I have minus 2FV. So when this FV is coming here plus FV, so I am going to get minus FV. So I am going to get here UV minus UF minus FV is equal to 0. Okay, let me erase this. So now dividing both sides, this is 10th point, dividing both sides by VUF. Okay, dividing both sides by VUF. So I am getting UV by UVF minus UF by UVF minus FV by UVF is equal to 0. So I can cancel UU and VV. I got here 1 by F, and here UU and FF. I got minus 1 by V, and FF and VV. I got here minus 1 by U is equal to 0. Now this implies 1 by F is equal to, taking these two terms that side, 1 by V plus 1 by U. So this is mirror formula. Okay children, I hope you have understood the derivation of mirror formula. This mirror formula can be used for both convex as well as concave mirrors, right? Now, next we are going to see the derivation of magnification. But in order to apply the mirror formula in the magnification formula, we must know a very important thing, that is sign convention. So we are going to study about the sign convention. Please try to understand why, because this sign convention is very important. If you don't understand the sign convention, then we won't be able to apply the mirror formula and the magnification to solve the problems related to convex mirror and the concave mirror. Okay, so please try to understand the sign convention. So the first point which you must know about the sign convention is all the measurements must be made from the pole of the mirror. Let me explain here. Suppose you are taking a concave mirror, right? So we have the pole here. This is the focus and this is the center of curvature. And this is the convex mirror. This is a convex mirror. And we have the focus and the center of curvature here. We have the pole here. Right. Now, all the measurements must be made from the pole of the mirror. That is, if you want to measure the object distance, or if you want to measure the image distance, or if you want to measure the focal length, we have to start measuring from the pole. Okay, for both the mirrors. So you'll understand this point more better in the next point. So the second point is measurements made along the direction of incident ray are taken positive. Measurements made opposite to incident ray are taken negative. Now this is the very important point in the sign convention which you have to understand. Let me say, in case of the concave mirror, the left side is the reflecting part. So therefore you are going to keep the objects always on the left hand side. We never took a case where the object is kept on the right hand side. If you keep the object here, the light rays will come here and it won't reflect. Image is not formed in this way. Okay, images will be formed only when the object is kept before the reflecting part. Okay, so let me say there, this is the object. Now, I have taken an incident ray from left to right. So the direction of incident ray, this is the direction of incident ray. Okay, left to right. Now, if you consider the convex mirror, the convex mirror. The reflecting surface is right hand side. So therefore I am going to keep the object here. This is the object. Okay. Now the light rays start coming from the object and the light rays come and incident like this. That is from right to left. The direction of the light rays here and here are different. Here it is coming from left to right and here it is coming from right to left. Always remember the direction of the light rays from the object towards the mirror, not from, don't remember it as left to right or right to left. In case of this, that is both the cases, always the light rays start from the object towards the mirror. Okay, now here, measurements made along the direction of incident ray are taken positive. Measurements made opposite to incident are taken negative. For example, here, if I want to take that is object distance. If I want to measure the object distance, I have to take a scale and start measuring from the pole. Okay, always what is the first point? All the measurements must be made from the pole. So start the measurement from the pole and I have the object here. So I have to start measuring from here towards the object like this if I want to make the object distance. Okay, and as I am measuring, look at this, I am going opposite to the direction of incident rays from left to right. But whereas as the pole is here, I am measuring from pole towards the object and I am measuring in an opposite direction. So therefore, object distance, if it is suppose 10 centimeters, you have to take it as minus 10 centimeters. Why? Because measurements made along the direction of incident are taken positive. Measurements made opposite to incident are taken as negative. For example, if this distance is also, let me say, this 15 centimeters, then what is that I have to write? U is equal to, that is object distance. Now see, always measurements must be made from the pole. So from the pole, you have to measure in this direction towards the object. And while measuring, you are going against the direction of incident ray. So you have to take this measurement also negative, minus 15 centimeters. So both the cases, object distance, we have seen that it is negative. So always remember children, always the object distance will be considered negative. Whatever numerical value is there, you have to take object distance as negative. Okay, right. Now look at this case. Let us see the focal length. What is the focal length? In case of concave mirror, focus is here, okay, and the pole is here. Always start measuring from the pole. As I am measuring from the pole towards the focus, see, I am measuring opposite to the direction of light rays, incident ray. So it is negative. The focus of concave mirror is always negative. Now look at this. How is the focus in case of convex mirror? Okay, see the focus is here, the pole is here, and as I am measuring in this direction, see the direction of the incident ray and this direction both are same. Therefore, you have to consider here positive. Okay, suppose it is the focus is suppose 5 centimeters. I'll take it as that is minus 5 centimeters. Okay, and here it is plus 5 centimeters. Okay, so from this what you can understand children, always the focal length of concave mirror is negative. The focal length of convex mirror is positive. Concave mirror is negative. Suppose if I say, anybody says that the focal length of a spherical mirror is minus 10 centimeters. What is that mirror? So minus 10. So if it is minus, then we can call that mirror is a concave mirror. Suppose anyway they say that the focal length is plus 20 centimeters. The focal length of a spherical mirror is plus 20 centimeters. What is it? They won't mention whether it is concave or convex. But in the sign convention, you must understand that since focal length is positive, you must think that that is a convex mirror. Okay? So that is the meaning of these 2 points. Now the last sign convention, object distance, height of the object, and height of image above principal axis is taken positive and below principal axis is taken negative. Okay, so let us consider one case, that is the first, that is when the object was beyond. So suppose this is F and this is C, and we kept the object here beyond C. The light rays, this is the first light rays, it is passing through F, and it is passing through F, it is reflected like this. Okay, and you got the image here. Now look at this. AB is the object, A dash, B dash, this is the image. Now see, here when you are measuring the height of the object, if you are measuring above the principal axis, if you are going above, you have to consider positive. And if you are measuring below, that is, look at this, it is inverted. It is inverted. When you are measuring the inverted image, it will be negative. And when you are measuring erect, if you are measuring upwards, then you are take it as positive. That is, we have seen the last case, when the object was between F and P, you got a virtual image, and the virtual image was erected. So we are going to erect images, you are going to get as positive. Inverted image, you are going to get as negative. So if anywhere, if the height of the image is minus 3 centimeters, then you have to understand that the image is inverted. Okay, and if you say that the height of the image is plus 10 centimeters, then you have to understand it is an erect image. Okay, so these are the meaning of the sign convention, and this is very, very important. Everybody must memorize this sign convention, and then we are going to apply this sign convention for the mirror formula and the magnification. Now next we are going to study about magnification. Okay, so after sign convention, now we are going to study about this magnification. Previously, in case of the concave mirror and convex mirror, we have seen the sizes of the object and the sizes of image are different. In some cases, we have seen that the size of the object and the size of the image both are same. That is, we are comparing the sizes. Okay, if suppose the size of the image is more than the size of the object, then we say that it is a magnified image. And if the size of the image is lesser than the size of the object, we say it's a diminished image. Okay, so in case of the numerical problems, okay, so we want a formula for the magnification. Now we are going to derive the formula for the magnification. So magnification is generally defined as, that is, size of the image, size of the image, size of image by size of object, size of object. And the size of the image I write as HI, and this HO, height of the image, height of the object. Okay, so we are going to derive the formula for that. Now I have taken a concave mirror here. This is the focus, this is center of curvature, and this is the pole. Now I am going to draw an object here. So this is the object, and let me say it is O dash. O dash. O dash is the size of object. Okay, right. Now two light rays I have to draw. This is the first incident light ray, and it passes through the focus. I hope we are able to draw the ray diagrams now. Right? Now the second, generally it comes from the focus and it travels parallel to principal axis. That is the second one. Or we can also bring a light ray through the center of curvature. It retraces its path. Now we can draw a light ray in this way also, which we did not include in the rules children. That is, if you are bringing a light ray and incidenting at pole This is the second incident right ray. Okay. And at this particular point, if you draw a normal, the principal axis itself behaves like a normal. So this will be angle of incidence, theta. Okay, theta 1, let me say, theta 1 is angle of incidence. Now, finding the angle of incidence, if you draw angle of a light ray, that is reflected light ray, which is having an angle of incidence, angle of reflection equal to angle of incidence, it passes like this. It passes like this. This is a reflected ray and this is theta 2. Theta 1 is angle of incidence and theta 2 is angle of reflection, and theta 1 is equal to theta 2. Okay, and these two light rays are meeting here. So I am going to draw I am going to get an image here. So that is I dash. I dash. Okay, so I dash is the size of image. Size of image. Okay, right. Now consider the two triangles. Look at the diagram here. Consider the two triangles POO dash. Okay, so it's a derivation now. So from triangles POO dash and PII dash and triangle PII dash. These two are similar triangles. Okay, POO dash and PII dash. These are similar triangles. If they are similar triangles, then the ratio of their corresponding sides are equal. So I am going to take II dash by OO dash. O dash is equal to PI by PO. Okay, I dash by OO dash is equal to PI by PO. Okay, now let us apply the sign convention here. Following the sign convention, what is I dash? Okay, I dash is the height of the image. Okay, and as we are measuring it downwards, I am going to show as minus. Okay, minus h, that is image. So hi minus hi. Okay, OO dash. OO dash, you are measuring upwards, so it's a plus HO. Okay, now PI, what is PI? PI, that is PI, right? The direction of light rays like this, and you are measuring, what is this I? This is the image. So PI is a distance of the image. Okay, so that is image distance, and that is taken as V. Plus or minus, see, always you have to start measuring from the pole. You are measuring in this direction, whereas the direction of incident is like this. So both are opposite, therefore you have to take minus. Okay, and next PO. So what is PO? Object distance. And always start measuring from the P, that is you are going to measure from here to here. See the both directions opposite, therefore minus U. Okay, so let me substitute here I dash, that is minus HI by OO dash plus HO is equal to PI minus V by minus U. Okay, so already we know that M is equal to HI by HO. So M is equal to, okay, minus hi by ho is equal to minus of minus becomes plus. So I will write v by u, and finally I can write m is equal to, so I am going to take here hi by ho, hi by ho, then I can write here minus v by u, minus v by u. So that is the final formula. I hope you have understood. So this is the expression for the magnification, the hi by ho, and when the size of the object and image are not given, if suppose the object distance and the image distance are given, then the formula which you have to take for magnification is minus v by u. Now, suppose value of m is you are getting as 1, then what does it mean is size of object is equal to size of image. Size of image. Suppose value of m is greater than 1. Value of m is greater than 1. Then it's a magnified image. Then it's a magnified image. Suppose value of m is less than 1. Then it's a diminished image. Then it's a diminished image. And there are two more things which are to consider about m. So about m is positive. M is positive. That means it's a erect image. And m is negative. Then it's inverted image. Then it's an inverted image. See children, m is equal to 1, size of the object is equal to size of the image, m is greater than 1, magnified image, m is less than 1, then it's a diminished image. If m is plus 1, let me say, then it means that as plus is there, it's erect. And m is negative, then it's inverted. Okay? And when I say m is less than 1, m is less than 1, you have to understand that I am not talking about less than 1 means I am not talking about that is minus 1. So for example, in generally in integers, minus 1 is lesser than 1. So suppose if I say m is minus 1, I don't mean that value of m is less than 1. No. Don't look at this sign here. M is equal to, look at this number, is equal to 1. If it is equal to 1, then size of the object is equal to size of the image. And m is equal to this minus sign. It means that the image is inverted. Inverted and size of the object is equal to size of the image. Okay. Minus 1 doesn't mean that m is less than 1. I hope you are following. Okay children, after finishing the magnification formula and mirror formula and after the sign convention, let me summarize quickly. And I hope you will be able to follow all this. So once again I have drawn all the diagrams children. First coming to the concave mirror when the object is at infinity, right? So now I am going to write these values depending upon the sign convention, okay? So first of all you must understand this is a concave mirror. 1, 2, 3, 4, 5, 6 cases are concave mirrors. And in case of concave mirror, without any doubt you please keep f value as negative. The focal length is always negative. Why focal length is negative? Because the focus is here and the pole is here when you are measuring. Okay, and the sign convention we have studied that always you have to start measuring from the pole. And as I am measuring from the pole towards the focus, see the direction, this is the direction of incident ray. So both are opposite. Here also same. Here also same. All these cases are therefore for f we are going to take as negative for all these cases. Negative. Negative, negative, here also negative, and here also negative. Suppose it is 10 centimeters, I am going to take minus 10 centimeters. Now coming to this convex children. Convex mirror. See the direction of light. The direction of light is like this. It is coming from right to left. And the pole is here. The focus is here. So how we are going to measure? From the pole, we are going to measure in this same direction. Therefore, f will be positive. So always for convex mirror, f is positive. For concave mirror, f will be always negative. And coming to object distance, whether it is concave mirror or convex mirror, object distance is always negative. That you have to understand, negative. This also negative. This will be helpful to you in the solving the problems. And here it is negative. Suppose the object is at 15 centimeters, then you can take minus 15 centimeters, okay, and you can apply in the formula, right? Now try to understand how we are going to give the values for the, that is the image, okay, the image distance, that is V. Okay, now here the first 1, 2, 3, 4, 5 cases, first 5 cases we are getting a virtual image. Sorry, you are getting a real image. You are getting a real image, right? Real. It's real. It's real. This is also a real. And this is a real. And here it is virtual. Virtual. Now, coming to the real image, you see the image is formed here and you have to measure the distance from the pole towards the image. So it is always, now it will be negative. Okay, and here also the same story, it is negative. So you have to understand, if it is a real image, then value of V will be always negative. This is a point you have to understand. So here also negative, here also negative, negative, and here, coming to here, look at this. The direction of the light rays from left to right, pole is here, image is here. So you are going to measure in this direction. Both are in the same direction, therefore you are going to get positive value. Why? Because it's a real image. So the last case is a virtual image. Excuse me, children. So the last case here is a virtual. So it will be positive. And here also it's a virtual, it is positive. Okay, children. 1, 2, 3, 4, 5, all are real images. Value is negative. V value is negative. Last case, it's a virtual image and V value is positive. And in case of the convex mirror, you are always getting virtual images, so you are going to get a positive. And now coming to, let us try to understand the M value, children, here. So here, it's a real image. So real images are always inverted or erected. It's inverted. It's inverted. Okay, so here also inverted. It's inverted. This is inverted. But here it is erect. It is erect. Okay. Since it is inverted, you are going to get the values as minus. Okay. You are going to get the values as minus. You are going to get a minus. Here also minus. Negative. Negative. And this is erect. This is positive. Okay. And here also you are going to get it's erect. So therefore M is positive. Now let us try to look at these values. Here it is diminished. So therefore M value will be less than 1. It will be less than 1. Not only less than 1, very much lesser than 1. Lesser than 1 means it can be 0.25 or 0.5. The values can be like this. That is minus 0.25, minus 0.5, like this. Now coming to here. So it's diminished. So here also M is less than 1. M is less than 1. Okay. And coming to here, equal, you see. The size of the object is equal to size of the image. So here the value of M is equal to 1. Value of M is equal to 1. Suppose the length of the object is 10 centimeters, then the image also 10 centimeters. So 10 by 10 you are going to get 1. M is equal to 1. Now coming to here, the size of the image is greater than the size of the object. It's a magnified. So if it's a magnified, then you are going to get M greater than 1. You are going to get m greater than 1. And coming to here, highly magnified image. So m is very much greater than 1. Very much greater than 1. And coming to here, so it's a magnified image. So I can write m is great, here also very much greater than 1. Okay, and here m will be less than 1.